When you consume processed foods, your insulin levels surge within 30 minutes. Contrary to the assumption that these foods are merely calorie-dense, they trigger a rapid hormonal response. The refined sugars and simple carbohydrates cause a spike in blood glucose levels, prompting your pancreas to release insulin to shuttle glucose into cells. While many believe processed foods are only about empty calories, the real story lies in this biochemical reaction. Insulin, a key hormone for managing blood sugar, suddenly floods your bloodstream, leading to a cascade of metabolic effects. This is the opposite of what many expect from a seemingly innocuous snack. Your body is not just digesting, it's reacting. The emulsifiers in processed foods disrupt your gut barrier within hours. While marketed for texture, compounds like polysorbate 80 alter the mucosal layer lining your intestines. This layer, crucial for protecting against pathogens, is compromised. Studies, such as one in Nature in 2015, reveal that these additives increase gut permeability. This can lead to a phenomenon known as leaky gut, where bacteria and toxins enter the bloodstream. Most people think of processed foods as just convenient, but they actively change your gut environment. The result is inflammation and immune system activation, a far cry from a harmless culinary ingredient. Your brain's reward system lights up within minutes of eating processed foods. High levels of salt, sugar, and fat activate the brain's pleasure centers, releasing dopamine, a neurotransmitter associated with reward and addiction. A 2017 study at Princeton found that rats given sucrose experienced dopamine surges similar to morphine. This contradicts the belief that food addiction is a myth. Your brain reacts as if you've consumed a drug. The pleasure centers become conditioned to seek more, explaining why stopping after just one bite feels impossible. Eating processed foods is more than a dietary choice, it's a neurological event. Processed foods can alter your gut microbiome balance in under a day. These foods lack the diverse fiber content found in whole foods, starving beneficial bacteria like Bifidobacterium and Lactobacillus. Instead, they promote the growth of bacteria linked to inflammation, such as firmicutes. This shift can be detected within 24 hours, as shown in a 2014 study in Nature. The assumption that gut health changes slowly is overturned by how rapidly your microbial composition can shift. Your gut isn't just digesting, it's transforming its resident population with far-reaching implications for your health. Within an hour of eating processed foods, your satiety signals may be overridden. These foods often contain high-fructose corn syrup, which impacts ghrelin, the hunger hormone. Normally, ghrelin levels decrease after eating, signaling fullness. However, processed foods can maintain elevated ghrelin levels, tricking your brain into thinking you're still hungry. A 2013 study in the Journal of Clinical Investigation found this effect leading to overconsumption. The commonly held belief that eating until full is natural is challenged when hormones are manipulated. Satiety is not just about feeling full, it's a hormonal interplay that processed foods can disrupt. Inside your digestive system, enzymes are hard at work breaking down processed foods. Amylase in your saliva quickly converts refined starches into maltose, a simple sugar. This rapid conversion provides a quick energy source, but it also leads to swift spikes in blood sugar. Your small intestine then secretes additional enzymes, maltase and sucrase, which further break down sugars for absorption. Interestingly, processed foods lack the fiber that slows this process, causing a rapid influx of glucose into your bloodstream. This enzymatic efficiency is a double-edged sword, leading to both rapid energy and potential metabolic stress. Your digestive enzymes are doing their job, but at a cost. Hormonal interactions unfold as processed foods enter your bloodstream. Insulin isn't the only hormone at play. Leptin, the hormone that signals satiety, is also involved. However, persistent consumption of processed foods can lead to leptin resistance. This means your brain doesn't receive the "I'm full" signal, prompting continued eating. A 2016 study in the journal Obesity revealed that a diet high in processed fats can impair leptin's ability to regulate hunger. This hormone cascade contradicts the notion that processed foods are just empty calories. They actively influence your hunger regulation system. Inside you, it's a complex hormonal dialogue. Your liver takes center stage in metabolizing processed foods. One major player here is fructose, commonly found in high-fructose corn syrup. Unlike glucose, fructose is primarily processed in the liver, where it can be converted into triglycerides, contributing to fatty liver disease. A 2018 study in the Journal of Hepatology showed that diets high in fructose lead to increased liver fat in just 10 weeks. This metabolic pathway is often overlooked compared to glucose metabolism. Your liver is not just processing nutrients, it's coping with potential overload, especially in the presence of excessive fructose. This is a silent, internal transformation with long-term implications. Inside your gut, processed foods influence microbial metabolism. Artificial sweeteners like aspartame can alter microbial diversity. A 2014 study in Nature found that these sweeteners induce glucose intolerance by shifting gut microbiome composition. The microbes break down these compounds, leading to metabolic byproducts that can affect insulin sensitivity. This microbial shift is not just a gut issue, it impacts systemic metabolism. Contrary to the belief that artificial sweeteners are a healthy alternative, they might be reshaping your gut flora in unexpected ways. The enzymes and microbes in your gut are not just passive, they're active participants in this metabolic interplay. Processed foods can affect the blood-brain barrier, an essential line of defense. High levels of saturated fats can increase barrier permeability. A 2015 study published in the Journal of Neuroinflammation demonstrated that diets high in processed fats weaken this barrier, facilitating the entry of inflammatory molecules into the brain. This isn't just a gut issue, it's a neurological one. Processed foods don't only influence your gut and liver, they can alter brain chemistry and function. Your brain is shielded by this barrier, but with a diet high in processed foods, its integrity is compromised. The blood-brain barrier is more vulnerable than often assumed. Chronic exposure to processed foods can lead to insulin resistance. This condition occurs when cells in your muscles, fat, and liver no longer respond well to insulin and can't easily take up glucose from your blood. Over time, your pancreas works harder to produce more insulin, but eventually it can't keep up, causing blood sugar levels to rise. A study published in The Lancet in 2020 found that diets high in processed foods contribute significantly to the development of type 2 diabetes. This isn't just about weight gain, it's about a slow, systemic failure in how your body processes sugars. Your metabolic system is under constant strain. Excessive consumption of processed foods can lead to gut dysbiosis. This is an imbalance in the microbial communities in your intestine, often characterized by a decrease in microbial diversity. A 2019 meta-analysis in Frontiers in Microbiology linked diets high in processed foods to reduced gut microbiome health. This imbalance can exacerbate inflammatory bowel conditions such as Crohn's disease and ulcerative colitis. With fewer beneficial bacteria, your gut is less capable of fighting off harmful pathogens. Processed foods don't just change your gut flora, they can trigger long-term gut health issues. Your gut ecosystem becomes compromised, affecting your overall health significantly. Long-term intake of processed foods is associated with increased inflammation. Persistent low-grade inflammation is a silent contributor to many chronic diseases, such as heart disease and cancer. Processed foods often contain trans fats and artificial additives, both of which can trigger inflammatory pathways. A 2018 study in the American Journal of Clinical Nutrition found that individuals consuming high amounts of processed foods showed elevated levels of C-reactive protein, an inflammation marker. This isn't just about immediate reactions, it's about chronic, underlying inflammation that can persist for years. Your body's inflammatory response is constantly being activated. Food companies often downplay the addictive nature of processed foods. The precise combination of sugar, fat, and salt is engineered to maximize palatability, triggering the brain's reward system. This engineered bliss point keeps you coming back for more, often overriding natural satiety signals. A 2022 report by the National Institutes of Health highlighted how these foods are designed to be irresistible. This isn't just about taste preferences, it's about biochemical manipulation that fosters dependency. Your brain's reward circuitry is constantly being stimulated, which can lead to habitual overconsumption. The food industry's practices are more calculated than many might realize. Perhaps the most startling fact is that your gut can begin to recover within days of eliminating processed foods. A 2021 study in Cell Reports showed that switching to a diet rich in whole foods restored microbial balance and reduced inflammation in as little as 3 days. This rapid change highlights the resilience of your gut microbiome. While long-term exposure to processed foods can harm, your body has an incredible capacity to heal. It's a reminder that dietary choices have profound impacts, not just on weight but on microbial health and metabolic processes. Your gut's ability to bounce back is a testament to its adaptability.